You're probably already familiar with ferromagnetism. Ferro means iron. An unmagnetized piece of iron, or nickel, or cobalt, becomes a magnet in the presence of a magnetic field. The effect is strong and lasts even after the magnet is removed. Paramagnetism is a similar effect, except that it's much weaker and temporary. Aluminum is a good example of a paramagnet. Here, I have a few milliliters of liquid oxygen, which sticks to the magnet. Diamagnetic materials are exactly the opposite of paramagnetic. They are always repulsed. Graphite is repelled by a magnet, always, both by the north and south end. Of course, the best diamagnets are superconductors, which at low temperatures provide exact opposite repulsion to whatever magnetic field is present when they're chilled. They are perfect diamagnets. The most famous and powerful diamagnetic is bismuth. The bismuth-powered boat sails toward the weaker magnetic fields. Diamagnetic objects like glass will rotate to avoid magnets. Here, we see that the glass is diamagnetic because it twists to get to the weaker magnetic field. But aluminum rotates into the field, typical of a parallel paramagnet. We see from the periodic table that aluminum has 3 valence electrons. That's 2s and 1p. And it's that unpaired electron that is free to be magnetized and attracted by the magnet. But what about a diamagnet, like water? In fact, water is repelled by a magnetic field. The electrons come to lower energy as they are moved away from the magnet. In conclusion, when something is a paramagnet or a diamagnet, it tells you what its electrons are doing. In the case of a paramagnet, it has at least one unpaired electron. In the case of a diamagnet, it has mostly paired electrons.